Welcome back to Cloud on Air, the journey from big data to AI. A big welcome to all of you joining us around the world. My name is Jen Bennett, the director in the Office of the CTO, along with my colleague Indranil Chakrabarti, who leads our product management for Cloud IoT. As a reminder, please submit your questions. Google experts are on standby to answer them. So you may have joined today because, like me, you believe in the future of a connected world and have a number of aspirations around what's possible. Or perhaps you've joined because you've heard a lot about IoT and want to learn more. New possibilities are emerging every day due to advances in technology, but married with imagination around what's possible. When the connected world meets machines that are learning, we realize opportunities of the intelligent Internet of Things. What does that connected world look like? Well, imagine for a moment how much valuable time you've spent hunting for parking, circling the block, getting more and more frustrated. What if parking was available when you needed it, where you needed it? Or perhaps like me, you travel quite a bit and have been delayed or stuck one too many times. Imagine no longer having schedules delayed or disrupted due to maintenance issues. Or perhaps you're passionate about energy and how we utilize energy in an optimal way, every day, everywhere. Maybe even closer to home, personalized medicine, made and tailored just for you. These aspirational goals are not that far away. With 8.4 billion connected things and counting, a number of possibilities are becoming reality every day. If we look at what happened when we connected billions of devices, we delivered new insights, new experiences. And this has led to new ideas, including AI-first experience. Along the way, we've learned quite a bit about connecting billions of things. The amount of data has exploded and will continue to grow. So petabytes, exabytes of data. You must master data. And Google's history in big data dates back to 2005. Everything from storage solutions like Bigtable, to MapReduce for data processing, to interactive analysis at scale with BigQuery. These technologies have become industry standards in the open source community and enjoyed the innovation of the broader ecosystem. And that same technology that powers such large applications as search and maps and ads is now powering numerous applications throughout the industry. Taking data and applying large-scale compute, we add intelligence through machine learning. Machine learning is not just for games. Whether we're talking about products like Google Home or Nest or Pixel, even Google data centers, we have taken connected to a new level by applying intelligence. In many ways, driving double-digit improvement in performance. But this transformation, enabling these aspirational goals to become reality, sits at the intersection of connected things, big data, and machine learning. So connected things that are learning. What's important to remember, though, is it starts with connecting things and taking that large-scale data and gaining better insight, delivering new experiences, leveraging machine learning to supercharge your ability to make those devices intelligent. So without further ado, I'm going to introduce my colleague Indranil, who will talk to us a little more detail about IoT.
Thanks, Jen. So Jen talked about the intersection of connected things, big data, and machine learning. And I'm Indranil, and I want to go a little deeper into the product offerings we have to get you a jump start into your journey for intelligent Internet of Things. So let's get started. Before we get into the product offering, I want to give you guys a quick demo. So I'm going to switch tabs here. So let's take the example of oil and gas. If you think about an oil and gas company, there could be hundreds or maybe thousands of rigs across the globe. And what some of these companies would want to do is to real-time monitor the status of each of these rigs and want to figure out if any of their components or their drivers need some maintenance. Because any downtime in these rigs, any minute of downtime can cost them thousands or in some cases millions of dollars. So here we've built a demo where we have simulated data, simulated oil rig data, and as you know, each oil rig has a number of components, right? So there are crown block at the top, and sometimes there are traveling block, and there are other components. Each of these components have multiple sensors. And so what we're showing here is using our Google Cloud Platform and simulating data from oil rigs, you can monitor real time for each of these components the different sensor data, value from the sensor data. So for example, here the component is the crown block on one of the rig, and we can monitor the cable tension, the differential pressure, the oil temperature, and even the viscosity. And this all is being monitored real time. So and if I go down a bit more, you can also look at the time series data from all these different sensors for each of these drives. So it's a pretty valuable set of data which you can use for real-time monitoring. Not only that, what you can also do is once you've collected enough data, you can now start building, using machine learning, you can start building models to predict the number of life cycles left for any particular component. Just now, as you see, we're tracking real time. You can predict the number of life cycles left for each component. And as you see, when you see that any component has gotten into a critical state where it requires maintenance, you can either schedule maintenance, like the way I can do it here, or you can set some rules to automatically schedule maintenance for you, so that you never have, as an oil and gas operator, you never face any downtime. So this is a quick screenshot and demo of how you can use Google Cloud Platform and the intersection of connected things with big data and machine learning to not just real-time monitor your operations of the oil and gas rig, but also be able to predict downtime and do maintenance so that you can avoid any downtime altogether. So here's how the architecture for this particular demo looks like. So we have oil and rig, as you can see, the rig on the left side. It's pulling oil, and we have simulated data from oil and rig, and all this data gets sent to Cloud IoT Core, which I'm going to go a little bit more deeper into in a minute. That data gets published to Cloud PubSub, and from PubSub, you can consume the data using Cloud Data Flow for real-time event processing, and you can build some complex business logic as well. Then from the Cloud Data Flow, the data gets stored into BigQuery, which, as you know, is one of our premier data warehousing and analytics tool, which you can use to not just store data, a massive amount of data in a cost-effective way, but you can also use it for doing deep dive analytics. Furthermore, we have CloudML, which you can use to run TensorFlow model, and you can use the data from which you have stored on Cloud BigQuery to train a model and then predict, in our case, the remaining life cycle for any component. So what we have here is we've taken an example of use case of predictive maintenance, applied it to oil and gas, and we're showing you how you can build an end-to-end solution using Google Cloud Platform and the different services we offer here. So I'm going to go back to our presentation and walk you through some of the components which we use and which we think you can use as you jumpstart your journey on intelligent Internet of Things. As you know, Google has over 2 billion monthly active Android devices that are connecting to our cloud infrastructure on a daily basis, and they transact a massive amount of data. We have more than 1 billion YouTube users connecting to our cloud infrastructure every day. So over time, we have built an infrastructure which can really scale to not only connect this massive amount of devices, but also be able to easily ingest a massive amount of data, store it cost effectively, and then you use our other services for analytics and machine learning. We've announced a product called Cloud IoT Core, which is built on the same infrastructure that is being used by Android devices and other Google consumer products, to really make it easy and simple for customers and partners and developers like you to build IoT application on Google Cloud Platform. So what is Google Cloud? What is Cloud IoT Core? So let me get a little deeper into Cloud IoT Core. Cloud IoT Core essentially it's a fully managed service to securely connect and manage your global device, IoT device network. What it means is it allows you to simply connect, make it really easy and simple to connect your IoT devices at scale in a secure way to Google Cloud so that you can start benefiting from the downstream services for Google data analytics and machine learning services. Cloud IoT Core has two key components. We have a protocol bridge, which allows you to connect your existing devices using industry standard protocol such as MQTT and HTTP. And the great thing about this protocol bridge is it's fully managed. So you don't have to worry about instantiating a VM or sharding your services as you scale. Whether you connect few devices or hundreds of thousands or even millions or billions of devices, we scale internally. You just connect your devices and you focus on building an application. We take care of scaling internally. So it has automatic load balancing, and Cloud IoT Core is tightly integrated with Cloud PubSub, which is our managed service for data routing and data ingestion. So it's great. It can give you a global access view and allow you to centrally manage and monitor all your globally dispersed devices. So that's for the protocol for connecting your devices. So we have a protocol bridge for connecting your devices. We also offer some key device management functionality. So you can, we care about security deeply. So with Cloud IoT Core, you can individually configure your devices, and we support asymmetric key-based authentication to make sure that each device is individually authenticated for connecting to Google Cloud. You can also update and control your devices. So we have the provision for you to send configuration updates or firmware updates and even some commands over to your devices via Cloud IoT Core. And the great thing about our Cloud IoT Core is when your application tries to send an update or configure a device, we take care of propagating that new configuration to the physical device when the device is connected. So you don't have to worry about whether the device is connected or not. You just use it, your application just connects, calls the APIs, and we take care internally of connecting the devices. We also have role-level access control. So we support IAM at Cloud IoT Core, which allows you to, at a very granular level, provide access control to a group of devices to a certain user. And finally, we have a rich set of APIs so that you can really build application on top of Google IoT Core. Another thing about Google Cloud IoT Core is it works seamlessly with other cloud services such as PubSub, Dataflow, and BigQuery and CloudML. So as showed before in the oil and gas demo, you can, once you have onboarded your devices and when you start ingesting data from your devices via Cloud IoT Core, you can use our downstream services such as BigQuery and ML to build either real-time monitoring system or even use CloudML for doing predictive maintenance and building predictive models as well. So with that, let me give you a quick demo of how the product looks, how you can use the product to get started. So we understand that as you're starting on your journey, many of you want to build some quick prototype, want to build some quick proof of concept to get started. So we have a simple UI on Google Cloud Console to get you started. So if you go to Google Cloud Console and scroll down, you would see a line item called on the menu called IoT Core. You click on that, and it takes you to a collection of registry. Now we have this notion of registry, which essentially is a collection of devices. So you can define one or multiple registry, and with each registry, you assign a particular region where you would want your device metadata and your device data to be stored. And also you can define the protocol and the PubSub topic, which I'll come to. So if I click on a registry, for example, we have created a registry here. So what you see here is it shows you the region, it shows you the protocol you support, it shows you the PubSub topic where the data will ultimately get published to, and shows you a list of all the devices which are registered on this registry. What it means is that each of this device, the data from each of this device will get published to the PubSub topic here, which you can then use to consume and send it to your downstream services. If you click on a particular device, for example, let's click here. It shows you some quick stats in terms of the last message that was published by the device. It also shows you the key, authentication key, which we're using for authentication, for the device authentication, and so on and so forth. You can also click here and you can see some more data around the configuration and the state history of the device. So let's get into let's start creating a registry, and I'll really walk through that process of how you can quickly create a registry, add a device, and get started. So I'm going to go back to the registry details, and I'll say I want to create a registry, and I can say, let's say demo. Today's let's say 17th of 2017. So I give an ID for the registry. I select a cloud region. We have 3 regions currently supported. So you can select either Central, US Central, or Europe West, or Asia, depending on the region where you want to store your data. By default, each registry supports both protocols, MQTT and HTTP. And you have to select a PubSub topic where all the data will get published to. So let's say I'm going to select this topic. We have also added a provision for you to select a topic to receive state updates from the device, which I'll come to in a bit. And once you've selected a PubSub topic, if you want to, you can also add your own CS certificate at the registry. And what it allows you to do is it allows you to verify that the devices when they connect with their public key, it verifies the ownership of the device. So if you have a CA which you work with and you want to sign all the keys or the private keys for all the devices by the CA, you could do that. In this case, for now, I'm just going to leave it as none, and I just create. Now, what this has done is it is allowing you. We want to make sure that we want to give access to the PubSub topic so that Cloud IoT Core can publish data from these devices. We say continue, and boom. So the registry has been created. Now you can start adding devices. So I can just say, for the simplicity, so let's say device 1. I'm going to call my device 1. And I'm going to say I want to do ES256. And let's see, I'm going to copy the public key. And so the way it works is when you're adding a device, when you're registering a device to Cloud IoT, we expect that you will have a private key which is being stored with the device somewhere securely, ideally using a TPM. And there are open source modules for you to generate the public key from the private key, and you would take the value of the public key and add it to this console as you're registering the device. You can also add server-side device metadata. So, for example, I can say manufacturer in this case is Google, just for the sake of simplicity. You can add firmware version. As 10.1.1. You can add up to 500 such server-side metadata, which you can further use downstream for searching or even for organizing your devices if you have a large number of devices. And you say add. And once you've added, that's it. You're all set. If you have a real physical device or even a virtual device which you want to test for, you can start connecting that device with the device ID, my/device/1. You can start connecting to Cloud IoT Core either using the MQTT endpoint, which is mqtt.googleapis.com, or the HTTP endpoint. And once you start connecting it, you would start seeing data and in terms of when was the last data published by the device, and so on and so forth. So you can start monitoring it, and you can even start sending commands. So a quick example I want to show you is I talked about receiving data, but here is a simple example where if I want to, I can just send a simple instruction or a command back to the device saying, fan on through. That's it. So what it does is this means that you have an API where you've sent, using the UI, you could send a configuration update or a command to the device. And when the device gets connected, Cloud IT Core will automatically send that new configuration to the device. And once it gets an ACK back, it will report it here. So it's really simple to get started. And if you have a physical device, you can start right away. So that was a quick overview of using Cloud IT Core from the console. There are a lot of, if you go to Google cloud.google.com/IoT, we have documentation, we have sample code for you to connect your device using MQTT or HTTP, and there are a bunch of sample codes which you can use to get started. But I wanted to give you guys a quick overview of how the console looks like, how easy it is to really get started and jumpstart your journey on intelligent Internet of Things. So going back to the presentation. So I give you an example of how you can build a predictive maintenance demo using Google Cloud IT Core and other cloud services such as PubSub, BigQuery, and others. We have an example here. There's a company called, and as Jen mentioned about, gave the aspiration of never to have worry about parking. We actually have a company, a customer of ours called Smart Parking Technology. They're based in New Zealand. And they're using Google Cloud Platform to connect all these devices which are installed at every different parking lots in parking garages and even on the curbside, on lampposts and others, to not only give real-time view to the drivers in terms of what particular parking lot is open and available, but they're also using all the data they collect from their sensors to provide a more intelligent demand forecast to the city of Auckland through their application that they've built using Google Cloud IT Core and other data analytics and machine learning services on Google Cloud Platform. So we're pretty excited about the potential we see here and how customers and our partners are building interesting solution using our platform. So I talked about Google Cloud and what you can do on the cloud side. I want to briefly touch upon Android Things, which is our operating system for Internet of Things. So the great thing about Android Things is it's built on Android. And what we've done is we've taken the stock Android, so you get the core benefits of Android, which is, it's got a secure boot, it's got a pretty large, strong developer ecosystem. So any app you build on using Android Studio for Android, that can be easily ported into Android Things as well. And the great thing about Android Things is it also can run TensorFlow. So if you have a model which you have trained on Google Cloud, you can run that TensorFlow trained model on Android Things device and get some insights and get some local insights. So Android Things is a great OS if you're looking for a fully managed operating system so that you don't have to worry about the firmware version, the security patches. Google takes care of all of it. And if you're really interested in figuring out a way by which you can do some edge compute, Android Things is a great option to have, and I would encourage you guys to look into that as well. And we have a large number of partners who are working with us to certify their SOMs. So Intel, Qualcomm, NXP, Raspberry Pi, and a number of them which are already listed on Android Things website. Another thing about Android Things is if you're running Android Things on your device or on your edge gateway, Android Things works seamlessly with Google Cloud IT Core. So here's an example where what we've done is you have a camera where we have trained the TensorFlow model to identify faces on cloud, and we constantly update the TensorFlow model as new employees join a company. And the Android Things camera can detect real time on the camera itself whether an incoming person is an employee or is a guest or is a stranger. So just an example of how you can use some edge processing and together with cloud to really offer an end-to-end compelling application. So finally, what's next? I mean, I'm sure you guys are thinking about Great, we have services on Google Cloud using including Cloud IT Core and big data services and machine learning services. So how do we get started? So there are really three things which we would really encourage you all to start looking into as you want to jumpstart your journey. One is go to cloud.google.com/IoT to get started with our product, Cloud IT Core product. Second is, as you think about your solution, I'm sure you're thinking about the hardware which you want to use to collect the data. So we already have a pretty robust set of hardware partners who have worked with us and have made sure that their hardware works seamlessly with Google Cloud IT Core. So you can choose a hardware kit. You can buy it from our site. If you go to cloud.google.com/solutions/IoT/kits, this link is also available from the product side, and that will allow you to give you a number of options for you to choose a particular hardware device to get started. And finally, if you want to build a quick prototype, go to our quick start document, which is cloud.google.com/IoT/docs/quickstart. And we have a step-by-step instruction with sample code for you to get started in building your application. So finally, thank you, and we're very excited with what you can build with Google Cloud IT Core and Google Cloud Platform as you get on your journey for intelligent Internet of Things. Thank you, and stay on if you're interested in listening to some more sessions on big data and AI platform. Thanks.
Exactly. Now I'd like to welcome back those of you who just learned about real-time insights. We just finished talking about how Google has reached 100% renewable energy for both its data centers and offices. Joanna, what is your favorite thing about our data centers?
Well, I've never been to one because they're really protected.
Yeah.
But I do think it's really cool how we use our own buildings to test our machine learning and AI algorithms.
Nice.
For example, our machine learning controlled AC systems notice that they can prevent server fires by cooling areas of the building in advance of large batch jobs instead of simply trying to cool active machines.
Wow.
And so that's really cool stuff that theoretically someone could have thought of, but having the computer program notice it that much faster made us more effective and better able to save money as a company.
Oh, fantastic. Yeah, I mean, it's really amazing some of the ways in which you can use these AI processes to improve things which aren't kind of obvious, right? And so being able to use that to analyze temperature trends within a large building and being able to figure out how can you modify the way that you're cooling things to not just be more efficient, but actually to reduce the possibility of fires in the data center. It's kind of amazing. It's time to welcome back the AI track. Welcome. We've been discussing the clever and green data centers that Google uses to power all of the Google Cloud products that we've been talking about today.
Exactly. And one of the great things about a large company is that we have the actual physical space with interesting enough needs to play with. And these kinds of experiments are what really let developers hone the algorithms that we offer to others. So I think we should go ahead and introduce the next sessions. What do you think?
Outstanding, yes. We've got 3 more wonderful sessions along the same tracks that we have been looking at today. For the big data track, there's the Zen Guide to Data Preparation for Analytics, hosted by Eric Anderson.
For AI, Zach Stone and John Barris will take you through accelerated machine learning in the cloud. And in industry solutions, Jen Bennett is back, and she's discussing the new age of manufacturing.